the phenomena of the change in the path of light as it passes from one transparent medium to another, and this phenomena is called refraction of light. Now this can be shown by a diagram. For example, we have a system of two medium, and these media are air and water. So the medium I am considering are air and water, and this is the interface between the two. So here we have water and this is air and water. Light is traveling from air to water. This is the normal to the interface, and light is incident on this interface such that it makes angle I, and this angle is called incident angle, and this ray that is incident on the interface is called incident ray. So the path along which the light travel in first medium, this is the first medium from which light coming, right? So the path along which the light travels in the first medium is called incident ray. This is incident ray, and the angle which this incident ray form with the normal to the interface, that is angle I, is called incident angle or angle of incidence. So here I is angle of incidence. We have to note down that this angle of incidence is between the incident ray and the normal, not in the incident ray and horizontal or the interface. So normal के साथ बनता है incident ray, normal और incident ray के बीच में जो angle बनेगा, that is angle of incidence. Now if there is no change of medium, then light will go like this. This is the initial direction of light. But since the medium changes from air to water, right? Air has low density in comparison to water. So air and water के interface पे refraction होगा, and because of that we get the ray bended. And now this bended as per the rule कि अगर ये move कर रहा है rare to denser, then it bend towards the normal. And if suppose there were medium जहाँ पर light travel कर रही होती from denser to rare, means water to air, then in that case it bend away from the normal. We will see those examples also, but for now it is rare in comparison to water. Water is denser in comparison to air. So light will bend towards the normal. Now towards the normal means if this is the initial direction, then it will come towards the normal. So it will be like this. It will bend towards the normal. So this is the change of path of light or the bending of light, which is known as refraction. This phenomena is called refraction. The ray that we get after refraction is called refracted ray. Initially it was incident ray. In second medium the ray we get is refracted ray, and the angle that this refracted ray form with normal is called angle of refraction or refraction angle or angle of refraction. So angle of refraction is the angle formed by the ray with the normal to the interface. So I is angle of incidence and R is angle of refraction. In first medium the path of ray is called incident ray. In second medium it is refracted ray, and we have to note down the point. Then if the light ray is moving from rarer to denser medium, it bends towards the normal, just as happen in the case of air and water. However, if it moves from denser to rare, then it bends away from the normal. Let's have an example for the second case. So suppose for that we have the system of glass and air. Okay, so this is the interface. First medium is glass, means light is traveling from glass to air. So now in the combination of glass and air, glass is denser in comparison to air, and this is rarer medium. So now light is traveling from glass to air, means rare to denser medium. If this is the normal and light is incident like this, making an angle of incidence or incidence angle I with the normal, then its path should be like this. If there is no change in medium, then its path should be like this. But light is moving from denser to rare medium, that's why it passes from denser to rare medium, that's why it bends away from the normal. So it should be like this. It bends away from the normal, and the angle it makes with normal is called angle of refraction. So this is called refraction while light is passing from denser to rarer medium. In first case, where light passes from rare to denser, angle of incidence is more than angle of refraction. This angle was more and this was less. While in second case, where light passes from denser to rarer medium, in this case angle of incidence is less than angle of refraction. These are the two cases. But there can be a situation where light is incidence along the normal, means it is making 0 degree while incidence. So in a situation where angle of incidence is equal to 0 degree, that means light passes along the normal. So if this is the normal to the interface, then light is passing along the normal. Incidence, angle of incidence is 0 and light is coming to the interface along the normal. In that case, irrespective of the media, means whether which is rare or which is denser, the light will pass undeflected along the same line. Means if angle of incidence is equal to 0, in that case angle of refraction will also be 0, right? So if light is incident at 0 degree, that means it is coming along the path of the normal at the interface, then it remains undeflected and pass in this at the same path in the other media also, in the other medium also, and angle of incidence as well as angle of refraction both are 0 degree in that case, irrespective of the density of medium. So this is the three important cases that we have to remember while studying refraction. This is the nature of light, how it bends when it goes from one medium to another. Now, as we have studied reflection and then there were two laws of reflection similar in case of refraction, here also exist two laws which are very important whenever we are studying about refraction, so we have to keep those in mind. So next we are going to study about the laws of refraction of light. So the phenomena of refraction of light that we are studying, it obey two laws. There are two laws of refraction. Let's start with the first one. So first law is, this law states that the incident ray, the refracted ray and the normal to the interface, as we have seen in the diagram, there are three lines. First is the incident ray, second is the refracted ray and the normal to the interface, and all those at the point of incidence, all these three lines at the point of incidence all lie in the same plane. So this is the first law of refraction, that it means if this is the interface, right, if this is the interface, so normal, incident ray and refracted ray, so this point, this is the point of incidence, right, this is the point of incidence. So at the point of incidence, incident ray, refracted ray and normal all lie in the same plane. This is about the point of incidence. So the first law states that the incident ray, comma, the refracted ray and normal, right, the incident ray, the refracted ray and normal. Now this normal is to the same interface, so normal to the interface at the point of incidence, at the point of incidence all lie in the same plane. So this is first law of refraction, that incident ray, refracted ray, normal to the interface at the point of incidence all lie in the same plane. Now moving to the second law of refraction. Second law of refraction is also known as Snell's law. We also call it as Snell's law, and it states that the ratio of sine of angle of incidence, means angle of incidence का sine, that is sin I, इसका ratio लेना है हमें to the sine of angle of refraction, that means sine of angle of refraction. This quantity is a constant. So second law or Snell's law states that the ratio of, statement for it is the ratio of sine of angle of incidence. Sine of angle of incidence means sine I, and the sine of angle of refraction, that means sine R, is constant. And this constant means sin I upon sin R, this constant is called refractive index of second medium with respect to the first medium. So if light is passing from medium 1 to medium 2 and showing refraction like this, this is angle of incidence and this is angle of refraction, and we find sin I upon sin R, and this come to be a constant, then this constant is equal to refractive index, we call it as refractive index of medium 2 with respect to medium 1. Now how to represent it? It is represented by the letter mu. Mu represents refractive index, and we have to show that it is the refractive index of medium 2 with respect to medium 1. So we write it as mu 2. Mu 2 is the refractive index of medium 2 with respect to medium 1. Then we can write 1 here. It shows that it is with respect of medium 1. So this value sin I upon sin R, where I is the angle of incidence in medium 1, R is the angle of refraction in medium 2, is constant, which is equal to the refractive index of medium 2 with respect to medium 1, and is given as 1 mu 2, and this law is called Snell's law. Now what is refractive index? We say that this ratio is equal to refractive index, then we have to define the refractive index also. So let's talk about refractive index of a medium. Now to understand refractive index, first we have to understand the fact that whenever light travel from one medium to another, its speed changes. The speed of light that we study 3 into 10 to the power 8 meter per second, that is not constant, it is for vacuum, right? So when it moves from vacuum to another medium, or one medium to another medium, its speed changes. Then the ratio of speeds is called refractive index. So refractive index, first I am defining absolute refractive index, then I'll define relative refractive index. So absolute refractive index का मतलब है that this is the refractive index of a medium with respect to vacuum, right? Absolute refractive index means this is the refractive index of the medium with respect to vacuum. So if I am talking about the refractive index of air with respect, refractive index of glass with respect to vacuum, then it will be the absolute refractive index of glass, and it is equal to the speed of light in vacuum. So it is taken with respect to vacuum upon speed of light in medium. Now this medium is that जिसका हमें refractive index निकालना है. So suppose we want to find the absolute refractive index of glass, then it will be C, this value is C, 3 into 10 to the power 8, this is fixed. So it will be C upon speed of light in glass. If I am talking about water, then it will be absolute refractive index of water is equal to speed of light in vacuum upon speed of light in water, and it is given by mu is equal to C upon V, where V is the speed of light in the given medium and mu is the refractive index of that medium. Now we can also define this refractive index in terms of wavelength, as we know that when light moves from one medium to another, its frequency can't change. That is the property of that light ray. So frequency remain constant whether that light is in air or water or glass, that will not change, but wavelength get changed as per the medium. So we can also define refractive index in terms of wavelength, as we can write this speed of light in vacuum is equal to wavelength of light in vacuum into its frequency. Wavelength into frequency is equal to speed. This relation we have already know. And in case of medium, it will be wavelength of light in medium into frequency, because frequency remains same whether it is in vacuum or in that medium. So this implies that the refractive index can be written as the ratio of wavelength in vacuum to that in medium. That means the refractive index of a medium can be defined as the ratio of wavelength of light in vacuum to its wavelength in that medium. In that case, this mu is the absolute refractive index of light in the given medium. So this was absolute refractive index. Now we'll talk about relative refractive index. So in case of relative refractive index, there will not be vacuum. There are two medium, right? Two media, and we will try to find the relative refractive index of one medium with respect to the another medium. So to define relative refractive index, there must be two medium, let it be medium 1 and medium 2. Now ray is traveling from 1 to 2. The light ray is passing from medium 1 to medium 2 and showing refraction. Now I want to find the refractive index of medium 2 with respect to 1 mu 2. So that means refractive index of medium 2 with respect to 1. Then it is defined as the ratio of speeds, right? Ratio of speed of light in medium 1 upon in medium 2. So V1 upon V2 is the refractive index of medium 2 with respect to 1. और simply we can remember that कि जिसका हम refractive index निकाल रहे हैं, its speed will be the denominator in both cases, whether it is absolute or whether it is relative. जिस medium का refractive index निकाल रहे हैं, उसका speed will be denominator, and जिसके रिस्पेक्ट में निकाल रहे हैं, दैट विल बी द न्यूमरेटर. सो v1 upon v2 represent the refractive index of medium 2 with respect to medium 1, and this is the relative refractive index, right? This is relative refractive index. If the medium 1 is vacuum, then in that case it becomes absolute refractive index. Now, since the refractive index is a pure ratio of speeds, so it has no units, no dimensions. Okay, so refractive index के लिए no units and no dimensions. Now, the factors on which the refractive index of a medium depends are refractive index of some medium depends. These are, first is the nature of the medium, because nature of the medium actually decides ki in that medium what will be the speed of light. So nature of medium is very important. If we change the medium, speed of light will change and refractive index will also change. So it depends on nature of medium. Also it depends on wavelength of light used. Next, it depends on the temperature as well as other natural surroundings, means it depends on the nature of surroundings और द सराउंडिंग मीडियम. सो जो भी उसके आसपास में मीडियम है जिसको हम यूज़ कर रहे हैं, दैट विल ऑल्सो अफेक्ट द refractive index of the given medium. So these are the four factors on which the refractive index depend. Now what is the cause of refraction? This is the main thing. Refraction हो रहा है, we can observe that light is bending, but what is the reason for that? So let's see what is the cause of refraction. The main cause behind the phenomena of refraction is the change in speed of light, when it passes from medium 1 to medium 2. So the reason is change in speed of light, and what it signifies is if the refractive index is 1 mu 2 and is given as sin I upon sin r and is equal to v1 upon v2, that means light is passing from medium 1 to medium 2, then this change in speed is responsible for the phenomenon of refraction. Its ratio is given as refractive index, and this refractive index represents that the medium is denser or rare. How it represent that? So for this we can see, now if v1 is greater than v2, now I am taking first case, if v1 is greater than v2, then in that case this ratio will be more than 1 and 1 mu 2 will be greater than 1. That means the refractive index of medium 2 with respect to 1 is greater than 1, or we can imply that sin I upon sin r is greater than 1, or sin I is greater than sin r, and this implies that I is greater than r. So if I is greater than r, this shows that light ray bends towards the normal, right? If I is greater than r, that means incidence का angle ज़्यादा था, refraction का कम हो गया, so light bends towards the normal. And if it is so, if light is bending towards the normal, then the medium, the second medium that we have will have high density or will be optically denser than medium 1. This shows that the medium 2 we have will be optically denser than medium 1. This is the case. Now vice versa of it, if v1 is less than v2, in that case the refractive index will be less than 1, sin I less than sin r and I less than r. This shows that incidence angle is less than the refraction angle. That means light is bending away from the normal, which shows that medium 2 is rarer, optically rarer in comparison to medium 1. So basically it shows the nature of medium or how the ray will bend when it passes from medium 1 to medium 2, and that is the significance of refractive index. That's why we are studying a refractive index, so that we can know the nature of medium, whether it is optically rarer or denser in comparison to each other, and how light behave in that. Okay, so this is the physical significance of refractive index, and the cause of refraction is the change in speed of light when it passes from medium 1 to medium 2. So this was all about the refraction.